Advanced JAX-RS features. The Java API for RESTful Web Services JAX-RS, defined in JSR 311, is designed to make it easy to develop applications that use the REST architecture. This chapter describes advanced features of JAX-RS. If you are new to JAX-RS, see Chapter 19, Building RESTful Web Services with JAX-RS before you proceed with this chapter. JAX-RS is part of the Java EE 6 full profile. JAX-RS is integrated with context and dependency injection for the Java EE Platform 401, Enterprise Java Beans EJB technology, and Java Servlet technology. The following topics are addressed here. Annotations for field and bean properties of resource classes, subresources, and runtime resource resolution integrating JAX-RS with EJB technology and 401 conditional HTTP requests, runtime content negotiation using JAX-RS with JAXB, annotations for field and bean properties of resource classes. JAX-RS annotations for resource classes let you extract specific parts or values from a uniform resource identifier URI or request header. JAX-RS provides the annotations listed in the following table. Table 20-1 Advanced JAX-RS Annotations. Annotation description. Context injects information into a class, field, bean property, or method parameter. Cookie param extracts information from cookies declared in the cookie request header. Form param extracts information from a request representation whose content type is application. X. Formula encoded. Header param extracts the value of a header. Matrix param extracts the value of a URI matrix parameter. Path param extracts the value of a URI template parameter. Query param extracts the value of a URI query parameter extracting path parameters. URI path templates are URIs with variables embedded within the URI syntax. The path param annotation lets you use variable URI path fragments when you call a method. The following code snippet shows how to extract the last name of an employee when the employee's email address is provided. Path. Employees. First name. Last name. Domain. COM public class emp resource. GAT. Produces text. XML. Public string get employee last name. Path param last name string last name. In this example, the path annotation defines the URI variables or path parameters first name, last name, and domain. The path param and the method parameter of the request method extracts the last name from the email address. If your HTTP request is GT, employees, John, Doe, me company, com, the value, Doe is injected into last name. You can specify several path parameters in one URI. You can declare a regular expression with a URI variable. For example, if it is required that the last name must only consist of lower and uppercase characters, you can declare the following regular expression. Path. Employees. First name. Last name AZAZ. Domain. Com. If the last name does not match the regular expression, a 404 response is returned. Extracting query parameters. Use the query param annotation to extract query parameters from the query component of a request URI. For instance, to query all employees who have joined within a specific range of years, use a method signature like the following. Path. Employees. GAT public response get employees. Default value 2002. Query param min-year and min-year. Default value 2010. Query param meg-year and meg-year. This code snippet defines two query parameters, min-year and meg-year. The following HTTP request would query for all employees who have joined between 1999 and 2009. Get employees mag-year equal 2009 and min-year equal 1999. The default value annotation defines a default value, which is to be used if no values are provided for the query parameters. By default, JAX-RS assigns a null value for object values and 0 for primitive data types. You can use the Default value annotation to eliminate null or zero values and define your own default values for a parameter. Extracting form data. Use the form param annotation to extract form parameters from HTML forms. For example, the following form accepts the name, address, and manager's name of an employee. Form action equal HTTP. Example. Employees. Method equal post. P. Field set. Employee name. Input type equal text name equal int name tab index equal 1. Employee address. Input type equal text name equal emp address tab index equal 2. Manager name. Input type equal text name equal manager name tab index equal 3. Field set. P. Form. Use the following code snippet to extract the manager name from this HTML form. Post. Consumes application. X. Form will encoded public void post. Form param manager name string manager name. Store the value. To obtain a map of form parameter names to values, use a code snippet like the following. Post. Consumes application. X. Form will encoded public void post multi-valued map. String. Form params. Store the message. Extracting the Java type of a request or response. The JAX-RS core context annotation retrieves the Java types related to a request or response. The JAX-RS core URI-info interface provides information about the components of a request URI. The following code snippet shows how to obtain a map of query and path parameter names to values. Get public string get params. Context URI-info multi-valued map. String. Query params equal UI. Get query parameters. Multi-valued map. String. Path params equal UI. Get path parameters. The JAX-RS core HTTP headers interface provides information about a request headers and cookies. The following code snippet shows how to obtain a map of header and cookie parameter names to values. Get public string get headers. Context HTTP headers HH multi-valued map. String. Header params equal HH. Get request headers. Multi-valued map. String, cookie. Path params equal HH. Get cookies. Subresources and runtime resource resolution. You can use a resource class to process only a part of the URI request. A root resource can then implement subresources that can process the remainder of the URI path. A resource class method that is annotated with path is either a subresource method or a subresource locator. A subresource method is used to handle requests on a subresource of the corresponding resource. A subresource locator is used to locate subresources of the corresponding resource. Requests on the subresource are then handled by something else. Subresource methods. A subresource method handles an HTTP request directly. The method must be annotated with a request method designator such as GAT or post, in addition to path. The method is invoked for request URIs that match a URI template created by concatenating the URI template of the resource class with the URI template of the method. The following code snippet shows how a subresource method can be used to extract the last name of an employee when the employee's email address is provided. Path. Employee info public class employee info public employee info. GAT. Path. Employees. First name. Last name. Domain. Com. Produces text. XML public string get employee last name. Path param last name string last name. The get employee last name method returns DO for the following GAT request. Get employee info. Employees. John. Doe. Oracle. Com. Subresource locators. A subresource locator returns an object that will handle a HTTP request. The method must not be annotated with a request method designator. You must declare a Subresource Locator within a Subresource class, and only Subresource Locators are used for runtime resource resolution. The following code snippet shows a Subresource Locator. Root resource class. Path. Employee info public class employee info. Subresource Locator. Obtains the Subresource employee from the path. Employee info. Employees. Empid. Path. Employees. Empid public employee get employee. Path paramid string id. Find the employee based on the id path parameter employee emp equal. Return emp. Subresource class public class employee. Subresource method returns the employee's last name. GAT. Path. Last name public string get employee last name. Return last name. In this code snippet, the getEmployee method is the Subresource Locator that provides the employee object, which services requests for last name. If your HTTP request is GET, employee info, employees, S209, the getEmployee method returns an employee object whose id is S209. At runtime, JAX-RS sends a GET, employee info, employees, S209, last name requests to the getEmployee last name method. The getEmployee last name method retrieves and returns the last name of the employee whose id is S209, integrating JAX-RS with EJB technology and 401. JAX-RS works with Enterprise Java Beans technology, Enterprise Beans and contexts and dependency injection for the Java EA platform 401. In general, for JAX-RS to work with Enterprise Beans, you need to annotate the class of a bean with path to convert it to a root resource class. You can use the path annotation with stateless session beans and singleton POJO beans. The following code snippet shows Enterprise beans that have been converted to JAX-RS root resource classes. Stateless. Path stateless bean public class stateless resource. Singleton. Path singleton bean public class singleton resource. Session beans can also be used for subresources. JAX-RS and 401 have slightly different component models. By default, JAX-RS root resource classes are managed in the request scope, and no annotations are required for specifying the scope. 401 managed beans annotated with request scoped or application scope can be converted to JAX-RS resource classes. The following code snippet shows a JAX-RS resource class. Path. Employee. id public class employee public employee. Path paramid string id. Path last name public final class empty tails. The following code snippet shows this JAX-RS resource class converted to a 401 bean. The beans must be programmable, so the employee class requires a non-private constructor with no parameters, and the empty tails class must not be final. Path. Employee. id. Request scope public class employee public employee. Inject public employee. Path paramid string id. Path last name. Request scope public class empty tails. Conditional HTTP requests. JAX-RS provides support for conditional GET input HTTP requests. Conditional GET requests help save bandwidth by improving the efficiency of client processing. A GET request can return a not modified 304 response if the representation has not changed since the previous request. For example, a website can return 304 responses for all its static images that have not changed since the previous request. A put request can return a precondition failed 412 response if the representation has been modified since the last request. The conditional put can help avoid the lost update problem. Conditional HTTP requests can be used with the last modified and the tag headers. The last modified header can represent dates with granularity of 1 second. Path. Employee. Joining date public class employee date joining date, get. Produces application. XML public employee. Path param joining date date joining date. Context request rec. Context URI info we this. Joining date equal joining date, this. Tag equal compute entity tag GUI. Get request URI. If rec. Get method. Equals GT response. Response builder RB equal rec. Evaluate preconditions tag. If RB. Equal no throw new web application exception RB. Build. In this code snippet, the constructor of the employee class computes the entity tag from the request URI and calls the request. Evaluate preconditions method with that tag. If a client request returns an if none match header with a value that has the same entity tag that was computed, evaluate. Preconditions returns a pre-filled out response with a 304 status code and an entity tag set that may be built and returned. Runtime content negotiation. The produces and consumes annotations handle static content negotiation in JAX-RS. These annotations specify the content preferences of the server. HTTP headers such as accept, content type, and accept language define the content negotiation preferences of the client. For more details on the HTTP headers for content negotiation, see HTTP 1.1 Content negotiation. The following code snippet shows the server content preferences. Produces text. Plain. Path. Employee public class employee. GAT public string get employee address text string address. Produces text. XML. GAT public string get employee address XML address address. The get employee address text method is called for an HTTP request that looks as follows. Get employee content type text. Plain 500 Oracle Parkway, Redwood Shores, CA. The get employee address XML method is called for an HTTP request that looks as follows. Get employee content type text. XML. Address street equal 500 Oracle Parkway, Redwood Shores, California country equal USA. With static content negotiation, you can also define multiple content and media types for the client and server. Produces text. Plain text. XML. In addition to supporting static content negotiation, JAX-RS also supports runtime content negotiation using the JAVAX, WS, RS, core, variant class and request objects. The variant class specifies the resource representation of content negotiation. Each instance of the variant class may contain a media type, a language, and an encoding. The variant object defines the resource representation that is supported by the server. The variant list builder class is used to build a list of representation variants. The following code snippet shows how to create a list of resource representation variants. List variant versus equal variant. Media types application. XML application. JSON. Languages NFR. Build. This code snippet calls the build method of the variant list builder class. The variant list builder class is invoked when you call the media types, encodings, or languages methods. The build method builds a series of resource representations. The variant list created by the build method has all possible combinations of items specified in the media types, languages, and encodings methods. In this example, the size of the versus object is defined in this code snippet as 4 and the contents are as follows. Application. XML, N, application. JSON, N, application. XML, FR, application. JSON, F. The JAVAX, WS, RS, core, request. Select variant method accepts a list of variant objects and chooses the variant object that matches the HTTP request. This method compares its list of variant objects with the accept encoding, accept language, and accept charset headers of the HTTP request. The following code snippet shows how to use the select variant method to select the most acceptable variant from the values in the client request. GAT public response get. Context request R list. Variant. versus equal. Variant v equal r. Select variant versus if v null return response. Not acceptable versus build. Else object wrap equal select representation v. Return response. OK wrap v. The select variant method returns the variant object that matches the request, or null if no matches are found. In this code snippet, if the method returns null, a response object for a non-acceptable response is built. Otherwise, a response object with an Oklahoma status and containing a representation in the form of an object entity and a variant is returned. Using JAX-RS with JAXB. Java architecture for XML binding. JAXB enables you to access XML documents from Java applications. JAXB provides annotations to map Java classes into XML. JAX-RS has built-in support for JAXB. You can add JAXB annotations to the JPA Entity Manager, and there is no need to use converter classes. The JAXB annotations within a RESTful web service indicate the XML structure that should be generated from that code.